Okay, very good morning, all of you. Today we'll discuss about the most important operator in the Python or in another languages. So the bitwise operator is there. So in that bitwise operator, we'll do the operation on bit by bit. Okay, so that means earlier we do the practical. Right now, we can able to perform the bitwise operator on a binary number. Binary number means what? A decimal number will be converted into binary, and then the logic will be applied. After that, we get the output, and again it will be turned into the decimal. That means what? Simply, the bitwise operator is applicable for int and bool only. Okay, so boolean type only. We cannot able to apply the bitwise operator for string, bitwise operator for fractional number, and bitwise operator for the complex number. That means we can just able to apply on integers and booleans. Let's took the representations where we perform the operations. So first of all, here will you depend. So in that section, we'll discuss what is the process of bitwise operator works on that. So for example, assume that if we have number, okay, so assume that you have to perform the operation on the integer numbers. Assume that this one is your number. So 10 is there and second 20 is there. And I want to perform the bitwise and bitwise or we'll discuss about that. Don't worry about that. Just let's discuss about the process, how it works. So I think that this one is a 20. So these are the decimal numbers where we can apply the bitwise operator logic. So assume that you have two numbers. The first process is nothing but the decimal number will be converted into the binary number. The decimal number will be converted into binary number. Okay. So this number will be converted into binary number. Here I'm trying to convert the decimal number into the binary number. So here I will use the binary number of 10 and similarly I will use the binary number of 20. Let's take some smaller value later on. So here I'm taking the value as 8. I will replace this older value. So the first, the decimal number will be converted into the binary number. So I'm giving just a part where we can convert the numbers or where what are the process to get the output. Okay, in the bitwise operator. Don't worry about that. So just this operation will be covered in the internal section only. We cannot get this information at the real time. Okay, so we will provide only decimal number and later on we will get the output. But what happens in internal we were discussing. Okay, so these are the decimal number in internal. This decimal number will be converted into the binary number, and after that they will perform some processing. Okay, so assume that the processing is something called as binary and okay, whatever it may be, binary or is there, binary and is there. Perform some operation and we get the output. Okay, so assume that the binary operation will perform and we get the single binary output. So we get as only 8. So don't worry about that. Why we get this number, we'll discuss later. What are the rules, regulation, what are the truth table, what is the meaning of unary operator, binary operator, everything we will discuss. So we get after processing this statement, we get the binary value and further again this binary number will be converted into decimal. So this is the process how bitwise operator will work. So this one is a process how bitwise operator will work and in that section we get the directly final output as okay. So don't worry about we are passing the two values and we're getting a single value with a different kind of options, so we get that add. So don't worry about that, just understand the process how the bitwise operator will work. So whenever we pass any decimal number, either we can pass the decimal number or either we can pass the only boolean value. We cannot able to pass the float, fractional value. We cannot able to pass complex number. We cannot able to pass the string. What is the reason behind that? Does anyone knows why we cannot able to pass the fractional, complex, and fractional complex values or string values? Does anyone know that? Ankit, are you there?
Yes, sir. I don't know, sir, about it.
Just think about that. If you don't know that, don't worry about that. Just think about that. See what I am saying. I have a decimal number and the internal process says that the decimal number will be converted into the binary. After that binary we will perform the operation, we get the binary result, and when we get the binary result again it will be converted into the decimal. So did you get any hint why we not use string, why we not use complex number or fraction number? Okay, don't worry about that. See, I will give the solution or answer for that. See, we cannot able to convert string. We cannot able to convert complex. We cannot able to convert complex fractional number into the binary number. And the bitwise operator is majorly focuses on only binary options. Okay, so that means if we have a number and that number will be converted into binary, then and then we can able to perform the operation. Okay, so when we talk about the fractional number, we cannot able to convert the fractional number into the binary, so we cannot able to use the binary. We cannot able to use fractional number inside the binary. When we talk about the string also cannot able to convert into the binary, so that's why we cannot able to use. And last one is complex is also able to convert into the binary. So when we think about the boolean is able to convert the binary, yes, because the true has a value 1 and false has a value 0, so that means we can able to convert the binary. So that means, so those number, if we can able to convert it into the binary form, then that will be allowed. So in that section, among the five fundamental database, the only two data types are allowed. So the first one is an integer and second one is a boolean. So did you get all the concept regarding the bitwise operator, the basic syntax, sorry, basic concept of that? So make a note of that. Such a type of questions will be asked in the interview. Why fractional number is not allowed in the bitwise? We need to specify the answer, the bitwise operator. In that bitwise operator, we cannot able to use a fractional number because we cannot able to convert the fractional number into the binary. We already seen in the fundamental data types. Okay, so this is about the structure where we can use. So that means we can use only decimal number and we can use only boolean value. Now we discuss about the bitwise operator. Only two fundamental data types are allowed. So we'll discuss about the what are the unary operators are available and what are the binary operators. These are the serial number and these are the symbols where we'll perform each and every operations. So the first one is a AND. After that, second one is a OR. So this is not explanatory mark. This one is only OR symbols. So this one is a OR and third one is a XOR. Okay, these three operators are called as a binary operator. For that, we require two operands. Note of okay. So for that, we for this two or three operator, three symbols, we require two operands. So that means we can call it as a binary operator. Okay. When we talk about these three, we required to use only one. Sorry. So when we talk about the single negation, so we can use we can call it as a unary operator. For that, we require only one operand. Okay. So again, for that left shift and right shift, we require two operands, one variable and one size. Okay, so we'll discuss one by one. So here is an AND operator, here is OR operator, XOR operator, negation operator is there, left shift is there, right shift is there. Okay, let's discuss one by one. We use an AND operator. Okay, so if we have to perform the operation in that, if you need to take the two inputs, okay, so that means if we have to use two values, that means true values, then and then we get the true value. So that means if we have two conditions, similarly in the logical statement, we did the operation of. So if the first statement is true and the second statement is true, then we will use a logical AND operation. But in the bitwise operator, if the first value is a 1 and second value is a 1, then and then we get the output as 1. Otherwise, rest of all outputs will be 0. That means first value must be a 10 and second value must be a 10. Okay, we'll do the practical and we have to table for that. In the or, if at least while performing the operation, at least one we require either in first side or either in second side, like 1 0 is there, 0 1 is there, or 1 1 is there. Okay, so in that section we get the 1, otherwise we get the 0. When we talk about the XOR, in that the cross bit, when we get the cross bit, then we will write the 1. Otherwise, we will write the 0. Cross bit means what? 1 0 or 0 1. When we get the same bits, okay, when we get the same bits, either 1 1 or either 0 0, we get the 0. Okay, so this type of operation we can able to perform, because when I trying to perform one operation, so I will show you like that. I don't know about that. I already specified the how the bitwise operator will work. So assume that here I am storing a is equals to 4, a is equals to 4, and b is equals to something called as a 5. And I am trying to perform the a and b operation. So we get the 4. We don't know about why we get the 4. Okay. We are providing the integer value and we are getting the integer value. But what happened in internal section? Okay. So which operation you are doing? So we am doing the AND operation. When I am trying to perform the OR operation, we get a different value. We get the different value. Why this different value we get? What is the reason behind that? We need to specify. See, these operation are the memory level operation. Really, we don't need that. Only in such a case we can use the bitwise operator different kinds of operation. But we are at least we know that how it works. What is the reason behind that? We'll discuss. So what about the negation? Negation, it's quite harder part as compared to the other things that, for example, when we think about AND or XOR, left shift, right shift, these are the very quite easy operation. But when we talk about the negation, it did not get any proper solution. Okay, some when we trying to search for the negation operation, so we did not get expert opinion or expert option. Okay, while trying to resolve the query. So in that case, I will solve that option. Okay. So I have two different kinds of solution for that. One of the solution I've been used in the C language, C++, or in Java language, because it's totally depend on the range. But Python operator does not support the range, so we cannot able to find that solution in the Python. Okay. So let's do one by one. So this is a truth table. This one is an operation. So when I trying to use the fractional number as a bitwise AND operations, we get the inner unsupported operand types for AND, float, and float. Okay, and I'm trying to use a string, then unsupported type as a string and string. So make a note of that. This operation cannot able to perform. Why? Because they cannot able to convert into the binary. And if it is not able to convert into binary, then we cannot able to use the option. Okay, operation. We cannot able to perform the operation. So we can apply the bitwise operator only for what? Int or we can apply the bitwise operator for what? Only for the int and boolean. We cannot able to apply for others. So these are the rules of bitwise operator. Let's discuss about the bitwise rule. And in that section, just we will have a rule for the AND, OR, and XOR. We don't have any rule for the left shift and right shift. So just we can use the we can perform the operation on a single operator, and that's why we do not have any rule. Okay. So for that we have rules. So let's discuss about the rules. So this one is a bitwise and bitwise or bitwise. Okay. So यहाँ confusion नहीं होना है. Okay, so when we talk about the logical operator, in that we are using a and d as a and, or as or, not as a not. Okay, so same thing if you're trying to use in another language, for example, in C language, C++, or in Java language, in the logical operator we will use a double and, double or, and not symbol. So in that we're trying to use that. And in bitwise operator, we'll use the single and, single or, and negation and like that stuff. So difference is that In logical operator in Python, we are using only A and D as AND, we are using OR as an OR, and we are using NOT as a NOT. Not we are using a symbols. We cannot able to use them. So the difference is that. So don't be confused. Okay, so while learning the other languages, we have some confusion levels. So don't be confused. So when we perform the same operation on bitwise, so here we have a bitwise AND, bitwise OR, and bitwise X. So what are the rules? We'll discuss about that. So if you want to perform the operation, like the plus, minus, and subtraction, we can able to perform the operation. What does it mean? So if you have a variable a and if you have a variable b and that variable a and b contains some value, and if you're trying to perform the addition, that means we are adding the first variable into the second variable. Same thing we will do in the bitwise operator also. We are adding the first element with second element, but certain conditions are available. So if you want to perform the addition in the, so all the operation will perform the addition. So in that option, when we perform the addition, we need to understand the bits. Okay. So if both bits are one, trying to perform the addition in bitwise operator. Okay, so we directly cannot able to perform 10 plus 10. First of all, we need to convert 10 into the binary, and again we need to convert 10 into the binary, and after that binary number operation we can perform. Okay, so if the both bits are 1, then only we can use 1, otherwise we will use 0. That means assume that if we have two options, 1 1 we get the 1. If we have two options 1 0, we get the 0. If we have two options 0 1, we get the 0. If we have two options 0 0, we get the 0. Okay. So that means if first bit is 1 and the second bit is 1, then the resultant will be the result will be as 1. Otherwise, the rest of all bits are the 0. So these rules are most important while learning the bitwise operator. Make a note of that. And these rules are same as it is available in other language also. C language, C++, and Java also. Okay. So same as it is JB rule है ये as it is rules available. When we talk about the bitwise OR operation, when we talk about the bitwise OR operation, in that case, at least one bit is one. At least one bit is one, and then at least one bit is one, then one. Otherwise, we get the zero. At least one bit क्या होना चाहिए आपका? One होना चाहिए from two bits. Okay. We need to perform the addition. For that, we have two bits. Among the two bits, at least one bit is one. Okay. At least one है मतलब at most two हुए तो भी चलेगा. There is no option. Okay, so at least one है, that means there is a two होगा तो भी चलेगा. So in that case, we get the one if we get at least one. Okay, otherwise rest of all bit will be zero. So don't worry about that. We'll do the practical and I will explain very briefly. Just remembering that. So if you have two inputs 1 and 0, so 1 and 0, and if you want to perform the addition for that, so 1 and 0 hai, so at least one bit is there, so we get the 1. 0 and 1 hai, so at least one we get, so we get the 1. Both bits are 1, at least 1 hai, at most 2 hai, so we'll get the 1. Both 0 hai, we don't have at least one bit, so we get the result as 0. So likewise we can able to perform the bitwise OR. And after that bitwise XOR, ये बहुत tricky option था. So in that section, just we are using an XOR operation. In that section, just if both arguments are different. Arguments means what? Inputs. If both inputs are cross. I already discussed that, the cross bit. So if both arguments are different, then one, otherwise zero. That means if the both bits input 1 and input 2, if the both bits are similar, we get the 0. That means what? 0 0 0 1 1 0. If the both bits if both bits are crossed like 1 0 and 0 1, then we get the 1, otherwise we get the. These rules are very important. So if you have any query regarding this rule, let me know. We'll discuss as we'll move for the input operation. So you will get the idea. So this one is a truth table, and we'll discuss about that how it will happen. Assume that this one is A as input and B as input, and we're trying to implement the operation on and or and it's. Okay, so I'm trying to use 0011 0101. Okay. So now I am performing A and B. A and B का rule क्या है? If both bits are one, then only one. So just A and B 000 0 1 0. Why? Because A is required one and B is also required one. Then and then we get one. Otherwise, all bits are zero. Here I'm trying to use 1 and 0. So 1 and 0, that means here though both the bits are not 1, that's why we get the 0. Why? Because A is a 1 but B is a 0, and we already told that if A is a 1 and B is a 1, then and then we get the 1. Otherwise no. So the last option, A is a 1 and B is a 1, so we get the 1. So this is the A option. So for that reason we require this logic. For that reason we require this logic. Okay. Let's do the OR operation. In that section, if at least one bit is required, so 0 0, we get the 0. So does we require, does we seen at least one in A and B? No. In that section, in the first tuple, in the first record, we did not get any one. So that means the resultant output will be 0. When we talk about the A and B for the next bits, here we have A as a 0 but B as a 1. So when I trying to perform the OR operation, we get the resultant as a 1 because it satisfies the condition. At least one we required in two input. So we get the, so similarly for the A and B, we use A 1 and B 0. In that case, also we get the 1. Why? Because it also satisfies the condition at least one we require. Also, we have 1 1, that means at least one means at most we can use 2. Okay, so don't worry about that. So, again, it will use 1. So, this is the truth table of A or B. We require this truth table while performing the operation. While performing the bitwise operation, we provide integer value, we get output as an integer value, but we don't know how we get that value. So, for that reason, we must understand this truth. Like in earlier example, I am using a is equals to 4 and b is equals to 5, and I am trying to perform the AND operation a and b, that means 4 and 5, we get the output as a 4. So what is the reason? Just we need to justify that, certify that. So for that reason, we need to understand this concept. Okay. So next one is A or B. If the cross bit, if the two different bits, if the bits, two different bits, okay. So if the cross bits are available, then we can use the X. Here, if the both arguments or both the bits are different, then 1, otherwise 0. So I am trying to use 0 0 0, 1 1 0. Both the bits are same. If both bits are same, we get the 0. Both bits are same, we get the 0. If both bits are different, 0 1 1 0. Hope so you have regarding that. I will do the practical, just 1 minute. So all student got the concept? Or does anyone have query regarding that? Spark, Indra,
Sir, clear.
did you get the concept?
Yes, sir. I got it.
Yeah. Pooja, Pooja, are you there? Shivani?
Yes, sir. Yes, sir. I got it.
Okay, Pooja. So, uh, with the practical, so we will get the idea regarding how it performs. So when we talk now, just assume that we talk about only first three operators. Okay, so first three options. Later we will discuss about the left shift, right shift, and negation. Okay, so first we will discuss about only three. So open ideally tool and we'll prove that this one is ideally tool. So in that I'm trying to use a variable one where one is equals to, here I will use the value as a 5. Another, is it visible to all?
Sir,
Yes.
it is visible.
Does you have any size issue? This variable one, shall I perform the program on notepad? So better understanding. We'll do it on
It is
because right now I also not visible clearly. Do it on don't worry about that. So here I'm performing, here I'm using one variable one. I'm trying to store as also I'm using a variable two, and in that section I'm using. Now I want to perform the operation in that double quote comma separation that I'm using operation var one var two. Pass the option var one. So we'll save the program. Then so see nine. Bitwise and dot py. The command prompt d drive cd pp program I bitwise py. Here we get the output as 4. Get the output as 4. So here we separate them. We get the clear idea. We get the output as 4. Now here I'm trying to perform a bitwise AND operator, and in that section I'm trying to pass the 5 value and second variable as a 4 value, and we get the 4 output. So let's check how it performs. First task, here I will write. What is the first variable? Var1 is there. What will be the var value? 5 is there. 5 is there. Okay. Now next task, we need to convert that 5 into the binary. Okay. So how will convert the binary number? Does anyone know? How will convert the given number into the binary number? Does anyone know? Because we require to know how we convert. See, by using ideally, we can able to convert. We have a function called as a bin. So you see here I'm convert binary of 5. So we get the output. Okay, so 1 not 1 0 b we skip, and this one is a binary of what 5. So again, if you want to calculate the binary of 100 or 10, we get the binary of 10 as a 1010. So this is a quite easy to perform the operation, but still if you don't know the function, then how will convert? Okay, manually we need to convert it. So Ankita, does you know that how will convert? Shivani, Ankita, Sachin is there. How will convert? These are the very basic things. I'm audible to all.
Sir,
I will convert then. Let me know, Yogeshwari. I will convert the given decimal number into the binary number.
सर मैन्युअली 8421 में काउंट किया जाता है तो 5 तो फिर 0101 उसकी वैल्यू होगी.
Yeah, true. So we will use what the rule of 8421. Okay, so in that section, make a note of that. The first number is 1. The double of 1 is 2. The double of 2 is 4. The double of 4 is 8. The double of 8 is 16. The double of 16 is 32. The double of 16 is 64, and the double of 64 is 128. Okay, so these are the 8-bit values. Okay, so make a note of that while performing the operation or negation. That means a complement. In that section, we need to use 8-bit. Okay, other than we can use appropriately. We can use the 4-bit also, or we can use the 8-bit also. Don't worry about that. Okay, so we can use this rule. Now I have to calculate the binary for this. Okay, so for that section, the last 4-bit is called as a nibble. Make a note of that. And first 4-bit is called as a upper nibble. And last 4-bit are called as a lower nibble. So we will use lower nibble while performing the AND, OR and XOR operation. And और XOR के लिए हम 4-bit ही use करेंगे. Okay, depending on, for example, if the value beyond the 15, then we will use more values. Okay, so in that section, while using the 8421, just we make note of that. We need to add the elements, and result must be a 5. Okay, and those elements or those digits are participate in the addition will get 1, and those are not participated in the addition will get 0. So here 8 plus 4, 12. So our value is 5. So here 8 is not possible. 4 plus 2, 6. So the value is not, still we get 4 plus 1, 5. The value we will get. Okay, so that means 4 and 1 is participated in the addition, and we got the proper result. So rest of all bits are 0. Rest of all bits are 0. Those are participated in the addition. We need to convert it into binary. So this is the rule 8421. So again we'll convert var2 into binary just by trying to achieve the result. Okay, don't worry about that. As a QRI. So here we have the same concept. Again here I'm trying to use 842. The value 8 is not participated, 1 is 4 is a participated, 2 is not participated, and 0 is not participated. This one is a binary of. So now we get the values in the binary form. Let's try to perform the AND operation. Okay. So here I'm trying to perform the AND operation. We write the statement 0 1 0. That we write var2 0 1 0 0. Now we are trying to perform the. So according to the AND operation, what is the rule? According to the AND operation, what is the rule? So the rule is if both bits are 1, then only 1, otherwise 0. Okay. So here I am trying to perform 1 0 0. Why? Because these two both bits are not 1. In that section, only 1 is there, and next bit 0 is there. So that's why we get the 0. So again 0 means 0. 1 1 means 1. 0 means 0. We get the. Now we trying to convert this binary number into what? Decimal number. So this operation will be going on in the internal sections. Don't worry about that. So what is the binary of this 0 1 4? So just we'll copy it and we'll paste 8 4 2 1 over rule. So here I'm trying to see, we get the 4. We get the 4. So that's why whenever we perform this operation, we get the value as 4. See, we get the value as 4. So let's take another value. This value is let's take another value. So here I'm using var1 is equals to 15. Okay. And here I'm using var2 is equals to. What is the first step? We need to try to convert it into binary, and we all know that how we calculate the binary. So the 15 binary, 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. That means all ones. So this one is a binary of 15. Okay. So now just var2. So var2 8 plus 4 12, value is 11, so 4 is not usable. 8 plus 2 10, 10 plus 1 11. That means 1 0 1 1. We need to perform the operation. So we'll perform the AND operation. 1 1 means what? We get the result operation as 1. 1 1 means what? 1. 1 1 means what? Again we get the 1. 0 1 means what? We get the 0. Why? Why we get the 0? Because both bits are not. We get the output as 1 0 1 1. So let's do that. Here I'm trying to use 8 2. 8 is there, 2 is there, 1 is there. So we get the output decimal as. I will calculate 8 plus 2, 10, 10 plus 1, 11. Okay, let's provide these two value 15 and 11. So here I'm trying to use this value inside that code. It's my code. Remove this statements. I'm trying to use first as 15 and second one as 11. I will save that program and trying to use that code. We get the output as now when we talk about we'll combine all this value and just we'll do the practical. So we'll perform the OR operation also. So where is my notepad? Here is a notepad. So this is about what? This is about the AND operation. Now we'll do for the OR operation also. Here we'll do OR operation. With that OR operation, just we have a rule of at least one record. Is one required. So here we get 1 as 1, 1 1 as 1, 1 1 as 1, 1 0 is also 1, and 1 1 as 1. We get this value, and when we try that value, we get the output as, just we need to understand the rules. Just we need to understand the rules. If at least one is there, then we get the result output as a. Okay, so result output आपको क्या मिलेगा? So in that section we get the output as 15. So let's do one more time for XOR. Okay. So you have to perform different kinds of operation. Here I'm trying to use XOR. So what XOR says, if both the bits are different, then we get 1, otherwise we get the 0. दोनों के दोनों बिट डिफरेंट होने चाहिए तो ही 1 मिलेगा, अदरवाइज 0 मिलेगा. So right now 1 1 is the same bit, so we get the 0. Again here 1 1 is the same bit, we get the 0. Here 1 and 0, these are the cos bit where we use 1, and 1 1 is same, so we get the 0. We get the 0 and to illustrate that we'll convert that into decimal. All the rest of bits are 0 except 4, so the output will be this output for the OR and this output for the X. Okay, so XOR. So this is the symbol of X. Now just we are trying to print this operation and let's cross check as we get the proper output. So yeah, I'm trying to use AND. We're using OR and this XOR. So here also I'm using cap. Let's save that program and I'm trying to execute that program by using the command prompt. We get the values 11, 15 and 4. Let's check this with values 11, 15, 4, 11, 15. We can cross check this value. AND operation we get the 11, OR operation we get the 15, and this we get the Let's try to implement one more program so you will get the brief idea regarding that in the two operators. So just here I'm using a var1 as a variable and using the value as 5. We'll calculate the binary. So 8421 rule capable नहीं होगा in that section. So we will use what 32 bit 1644 32 bit use करना पड़ेगा. So that just here I will write the binary. So 32 plus 8 it would be a 40 plus 4 4 and 1. So that means 1 will be participated, 0 will not participate, 16 will not participate. So 1 will be participated. That 30 plus 8, 40 will be there. 40 participated. This one is a binary of 54. Okay. So we'll calculate the binary for 19. So 32 is not used, 16 will be used, 8 will not use, 4, that means 16 plus 4 not used, and 2 plus 1. So this one is a binary of what? 90. Now we'll perform one by one operations. Okay. So in that section, just I will write statement and so let's start from the option. So 1 1 1 0 1 1 1 1 1 1 0 1 0 1 0 0. Both bits are 1, then we get the same 1 1 1 1 1 1. Get the same. So we get the output as 16 plus sorry, this is for 8 copy 32 16 8 plus 4 12 12 and plus 1 30. We get the 30. Okay. So let's do for OR operation. That is
Sir, binary value of 19 is not right.
Sir,
It should be 1, means 16, 2 and 1.
16 here I use 8. Okay, so here is a 0. 16 plus here also 0. 2 plus 1. Is it okay right now?
Yes, sir.
Mistake. Okay, so let's do one more time for the AND operation. For the AND operation 1 1 we get the 1. So 0 0 0. All bits are 0. Bits are 0. So we get the output as 2. We'll check for that. I think 16 plus 16 plus 4, 18, 18 plus 1, 19. Right? So right now we get the output as OR operation. That just we need to perform more operation on above these two numbers. Here we get the 1 1 1 1 1 1. That means all bits are 1. Okay, all bits are 1. That means we get the output as plus 16 48 48 plus 8 something called as 54 56 56 plus 4 60 54 plus 4 58 60 61. We get the 61 value. Okay, let's do one more time. 32 plus 16 48 48 plus 8 56. I think 48 plus 8 56 56 plus 4 60 60 plus 3 63. Okay, and after that we'll use or here I will use XOR. Okay, so Now cross bit, just we need to apply for this logic. Okay, cross bit, first bit will be 0, then 1, 1, 1, 1. All bits are 1, okay, except last bit 1, 1, 1, 1, 1. For this, that would be just need to check that. So I'm trying to use 45, save it. Let's try to execute that program. See, 1 we get, 63 we get, and 62. This is about what bitwise operator. I hope so you will get the idea regarding that. So if you have any query, let me know. We'll discuss. And just you need to do the homework for the values. Okay, so you will get operations and rest of part will continue. Pair one, we have provided only values 98, 72. Just we need to perform all the operations. Last value is 26. So you need to do the practical for that. Okay. Does anyone have query regarding that? So didn't understand the concept of bitwise operator. Yes. Did you get all the concepts?
Yes, sir.
Yes, sir. Yes.
Okay, just I will save the copy. Pooja, I think you have any question.
Yes, sir.
What's your question? Pooja, do you have any question?